Hello everyone, here is the solution for problem 1 in homework 11. So actually for this problem, we know that there is a stochastic process xt, which is a WSS process, and we know that the autocorrelation of process xt is denoted by Rx tau, and the power spectral density is denoted as Sxx omega. So firstly, we want to show that the autocorrelation is not only real but also even. So firstly, because xt is real and the autocorrelation is the expectation of xt plus tau xt, it is also real. So it also can be written as the Rxx t plus tau t, and it is the expectation of xt plus tau xt. So if we change the order of t plus tau and t tau, it will be xt times xt plus tau. Therefore, it can be written as the t and t plus tau. So it is Rxx negative tau, so which is even. So we show that the value of tau and the negative tau are the same, so it is even. Secondly, we will look at the spectrum density. So the formula for Sxx omega is from negative infinity to positive infinity Rxx tau e to the power of negative j omega tau d tau. So we explain the complex number, and it will be Rxx tau multiples cosine omega tau minus j times the integral of Rxs tau sine omega tau. So actually from previous we know that it is even and it is odd. So this part is odd, and then the whole part is 0. And this is even, and this is also even, so it is even. Therefore, this is equal to the negative infinity to positive infinity Rxx tau cosine omega tau. So because it is even, it can be written as the integral from 0 to infinity times 2. Therefore, since it is we can also written as, so because it is even, so the value of cosine omega tau is equal to cosine negative omega tau. So therefore this is equal to Sx negative omega. So we also show that the spectrum density is also even. So here we solve the we also need to prove that it is non-negative. So consider the following example. So xt comes into and WSS, we will have HW, then we will have YT. So firstly, we suppose that H omega is an ideal band path system, and H omega is 1 if omega is larger than omega 1 and smaller than omega 2, otherwise it is 0. We are going to find the expectation of YT square. So to solve this problem, so by the definition we will know that it should be from negative infinity to positive infinity times the spectrum. Therefore, because this is 1 from this interval and otherwise it is 0, so it can be simplified as from omega 1 to omega 2 as xx omega d omega. So it's always bigger than 0. So because we can randomly choose omega 1 and omega 2, so that this is positive in all the intervals, therefore it must we can conclude that as omega is non-negative everywhere. Now we solve all the problem.